Let us find the area by using a previous method, but by making use of the two equal sides and the angle that they form, which is not yet known. We have found the area before by making use of two sides of the triangle and the angle that those two sides form. However, on this occasion, we will surely not be using the two sides that were used on the previous occasion. Let us first take a look at the angles in the triangle. We have 36 degrees here. EDC is also, which is this one, EDC is also 36 degrees. We have ECD, which is 36 degrees, and EDC is also 36 degrees. It's an isosceles triangle, and we identify the two equal angles easily. Those two angles are already known. With the two equal angles already known, the other one is the rest of 180 degrees. The angle is therefore equal to, which is the angle at E, 180 degrees minus twice 36. The angle is therefore equal to 108 degrees. All of the angles in a triangle have a sum of 180 degrees. We have these two to be 36 degrees. The remaining angle will be the rest when we subtract those two from 180 degrees. That angle is therefore 108 degrees. The area of any triangle may be found by taking half of the product of any two sides and multiplying by sine of the angle that the two sides form. In these resources, this method of finding the area of a triangle will be coming up so often that it is going to be second nature for students to use it. Area is equal to a half AB sine C, which is our general formula, and I am not a slave to formula. I prefer to say that it is half the product of any two sides multiplied by sine of the angle that the two sides form. The two sides that we have there are the 4.9 centimeters equal sides, and the angle that they form is 108 degrees. There we have the two sides, each of 4.9 centimeters, and the angle 108 degrees that they form. We'll just go straight ahead. A, B are the two sides of the triangle, turn out to be 4.9, 4.9, and the angle that they form is that 108 degrees. We may shorten the appearance of this expression by saying that 4.9 is occurring twice in the area, so we are squaring that. Area is equal to a half 4.9 squared sine 108 degrees, and we'll see this kind of situation coming up quite often when we are required to find the area of a sector or the area of a segment from which we are taking the area of a triangle in a circle. Usually there is a triangle with two of the sides being radii of the circle, and we will therefore have the square of one of the sides of the triangle coming into play. And this is quite often seen when we are finding areas that are with respect to the area of a circle. When we simplify that expression, the result is 11.4 centimeters squared, or square centimeters, and that is the area. And notice that there is a slight deviation from the areas that we have found before, but this is expected when we are using trig ratios, because they are not generally rational, and rounding off sometimes causes a little deviation. By different methods, the areas are slightly different. Trig ratios are not always rational. Rounding the answers has a tendency to produce slight deviations. Download Richard James Mathematics Resources app from the Google Play Store and have all of your examination solutions, instructional manuals, and other electronic books and booklets in one place. Also, have all of our products and services at your fingertips and on the go. Call or WhatsApp 876-351-9689 or 876-318-8848 for all hard copy books and booklets to complement your studies. Significant discounts will be given to everyone who is registered with any of our programs.